I will be talking about function attributes in today's lesson. By the end of the lesson, you will be able to identify, describe, and write intercepts and increasing or decreasing functions, maximum or minimum points, asymptotes, O's, and end behavior. So function, domain range, and symmetry are not part of this video. So I'm going to discuss those in separate videos. So x-intercept is the point where a function crosses the x-axis. So it is the value of x when y equals to 0. So for example, on this very graph, we have two x-intercepts. So you can see them. So there's one in x equals to 1 and there is another one in x equals to 3. So for these 2 points, we have the point 1, 0 and 3, 0, okay, as the x-intercept. For the y-intercept, so it is the point where the function crosses the y-axis. So it is the value of y when the x is 0. And for this example, we have one y-intercept, which is located at y equals to 3. So if I want to write that in ordered pair, I'm going to write it at 0, 3, okay? Whenever you are writing the ordered pair, it's going to be the value of x first, and for the y-intercept, the x equals to 0 and the y equals to 3. So that's why we have 0, 3. So for increasing and decreasing intervals, we always move from the left to the right of the graph. So as we move on the left to the right of the graph, we ask ourselves, is the function decreasing, that is going down the hill, or increasing, that means it's going uphill, or it is constant, that is it is just at a level surface. So for this particular example, we see that from negative infinity to negative 5, that is negative infinity to negative 5, this function is going downhill. That means decreasing. Also, from positive 1, okay, to positive 4, the function also is going downhill. It's also decreasing. So that is why we can write the decreasing part to be negative infinity, negative 5, both close with parentheses, union. So this union is just like or, okay, 1, 4. So those are the interval of x where the function is decreasing. Again, whenever you are writing increasing and decreasing interval, you have to focus on the value of the x, not the y values. So for the increasing, so we see that from negative 5 now to negative 3, this function is going uphill, so it's increasing. Also, from negative 1 to positive 1, the function is also increasing. And from positive 4 to positive 5, the function is also increasing. So that's why we can write, for the increasing part, we can write parentheses negative 5, negative 3, then union negative 1, positive 1, union 4, 5. So over these 3 intervals, the function is increasing. So for the constant, so we can see that from negative 3 to negative 1, the value of y stays the same. Okay. Also, from positive 5 to positive infinity, the value of the function also remains constant. So that's why we can also write that from negative 3 to negative 1, the function stays the same, and from 5 to positive infinity, the function is constant. So that is how to write increasing and decreasing interval. Okay, you write them focusing on the interval of the x value as you are going from left to right along the function. So the asymptote is the line that a graph is approaching. So this is an example of a rational function. So, and if you look at this function, you can see that the blue curve, the graph, is approaching this red and this green line. So this red and this green, they are called asymptotes. But the red line is called vertical asymptote. Why? It's because it goes up and down. It crosses across the x-axis and it is parallel to the y-axis. So we call it vertical asymptotes. And this one is x equals to 3. Then the green one will be the horizontal asymptote. So again, asymptote is the line that a graph is approaching. So O's is a point of a discontinuity on the graph. It is where the function does not exist. That means in a O, the function is undefined. So in this particular example, we have only one O that is shown. So the O occurred when x equals to 5, y equals to 4. So at this 5, 4, there is a O. And that is why they normally put this empty little O on the graph. So that tells you that the function does not exist at that particular point. So when we now talk about the continuity, so a function is continuous when its graph is a single unbroken curve. So I discussed about asymptotes, I discussed about O. So a continuous function cannot have O, asymptote, or a jump, or a break. So let's look at these 5 examples. So for graph 1, you can see that the graph 1 has a break, okay, like you has a jump. So graph 1 is not continuous. So it is discontinuous. What about graph 2? Graph 2 also has an asymptote at x equals to a. So this is like a vertical asymptote at x equals to a. So graph 2 is also not continuous. What about graph 3? Okay, graph 3 has a hole, okay, at x equals to a. Graph 3 is also not continuous. Graph 4 is not continuous because look at it. The graph also have like a discontinuity. It has a hole and a jump. That graph 4 is also not continuous. So what about graph 5? Yes, graph 5 is continuous because it is a single unbroken line. So that is why that graph 5 is a continuous graph. So I want you to use this to practice. You may pause the video. Okay, are you able to get these answers? Okay, congratulations if you are able to get that. So let's move forward. The relative maximum, this is the highest point on the graph over a given area. Okay, so we call them relative because it is just the highest point over that particular area. It might not be the highest point over the entire graph. In this example, we have 2 relative maximum. So like if I ask you over the interval of, let's say, x equals to -5 to x equals to -1, what is the maximum point? Of course, it's going to be this point, -3, 2. Okay, so that is why that point, -3, 2, is the relative maximum. So we can write it like the relative maximum is this -3, 2 and this 2, 1. So what about the relative minimum? So this is the lowest point on the graph over the given area. And by now, maybe you are able to already figure it out that we have 2 relative minimum on this graph too. So, and they are shown by these 2 points. Okay, so the plural of minimum is minima, and the plural of maximum is maxima because we have more than one in this particular example. So that's why I'm using relative maxima and relative minima. So don't think it's a mistake. It's not. When we are talking about end behavior, we are trying to describe the graph as the value of x becomes either very, very small or very, very large. We are just describing how the graph actually ends. That's why we call it end behavior. As s tends to -infinity, so in this particular example, you can see that the y is decreasing too, and is tending towards -infinity. When x approaches -infinity, we say that the function also is approaching -infinity. What about the other endpoint? So when s is approaching positive infinity, we see that the function is still going towards the negative direction. That means it's also still approaching negative infinity. So for the second example, we can see that as x approaches negative infinity, okay, the function is approaching positive infinity in that case. So, and then the other endpoints, as s is approaching positive infinity, we can see that our function is actually decreasing. So, as s approaches positive infinity, f of s is approaching negative infinity. So, this is the end of the lesson. Thank you so much. Please remember to subscribe.